from that point, you measure everything else. What is the difference between Limelight helpers and y'all? So y'all is a special type of Limelight helper that is more Limelight helping. I'm pretty sure it allows you to help easily integrate more Limelight easier. Um, what's an example of some Limelight function or features of Limelight and Strike?
Y'all is originally started as a way just to make Limelight helpers a actual vendor dep instead of a single file. I find that actual vendor deps are easier to update, which means teams can take advantage of mid-season updates and multi-season updates. So you don't have to just find the file again and put it, you just click update. But
Right here. Mm-hmm.
yeah. So that's the main difference between y'all and Limelight helpers. Y'all will eventually have a simulation integration, which Limelight helpers does not, and probably won't ever. It's just been on the back burner because we're working on many other things.
You know, if I really desire the Limelight sim, I will add it to the beg and strike for this feature list.
Yeah, that
Visions.
definitely moves things up.
Yeah, but as of right now, I have a lot of other priorities. Shooting on the fly. But yeah. So hub tracking should be done this week, hopefully. My other
Speaking of shooting on the
programmer that's in
fly,
this call. Yeah.
we have someone in the call who has actually been working on it.
Whoa. Shall we have them talk now or in a later workshop? How do you guys feel like a Valentine's date where we talk about shooting on the fly just between programmers?
That'd be so romantic.
Really romantic. That's like my candlelit dinner right there. Head over heels for this code. I will definitely take a lot of inspiration and admiration from.
You
If
already have,
you
actually.
oh, awesome! So I'm
Ungato, the one of the kids from 2181 is here.
oh my god, 2181.
Yeah.
Hi,
Yep.
you
Hello.
done shooting on the fly?
Yeah. I mean, I've been kind of messing with it.
Is it a open source GitHub link?
Yeah. I'm pretty sure. Yeah, it's just on the 2181 GitHub, and it's I think it'll be called like turret targeting. Very interesting like that.
Awesome.
I can get the link
2180.
if anyone wants it.
Oh yes, please do. We all want it. I guess this is a pre-Valentine's Day gift. Okay, this chat is okay. Sorry, I just joined. Do you guys mean hub tracking? Okay, so this workshop was supposed to be about sim, but we got sidetracked to Limelight, and now someone has delivered hub tracking code right at my plate. So we're gonna sidetrack to that real quickly. So hub tracking is basically tracking the hub, so your robot's always or turret's always facing it, and then shooting on the fly. So it's one thing. Have you ever just thrown a ball like a basketball, right, into a basket? That's one thing, right? And then now you try running sideways while also shooting your basketball into that basket, and you're gonna notice it's a lot harder because you have to time it better. And with robot code, it does not have eyeballs or sensors. I mean, it does. It doesn't have eyeballs that could calculate that with split seconds, so we have to program that. Oh my god, the code's here. Gimme. So shooting on the fly is probably going to be the hardest thing this year. I've been trying to brainstorm like other ways you can make this game programmingly challenging, because last year it was your alignment code, right? Your auto align. This year it's definitely going to be shooting on the fly. It's going to be shooting while moving. because it's one thing to track the code, the hub, but that's when your robot's stationary. You also want to track it, shoot it, and also make that velocity calculation while that ball is spinning or the ball is shooting.
By the way, we've had
Is this
aiming at any point in the field in YGSL for about 2 to 3 years now. It's built
that
in the swerve
shows
input
aim
stream.
at-
Is that .aim?
Oh,
Yes, that is .aim. But .aim is not sufficient for shooting on the move because it doesn't have any feed forwards.
Yeah, unfortunate.
Yeah, I'm gonna showcase that, by the way, just like the YGSL feature. Because if you don't know, you just go to your swerve input stream. The swerve input stream is just taking all your headings and whatnot into here, and it's outputting a velocity, whatever. So I'm guessing I can just create. So I have my what is this? Drive base, swerve input stream. Where would I put that actually?
Your robot
That
controller.
robot controller.
It's .aim and .aim wow. The aim wow, can you just give it a Boolean supplier or or set it to true with a commands.run once?
Wait, I'm confused. Robot controller, robot container.
Container. My bad.
I'm like robot controller. What is this?
It was a new
That's a WPI lib class.
Yeah.
Okay. What is this? Default commands. You know, I just make a default command. Drive base. Do not make this a default command. That's a bad idea. But command. I hate this is like, come on, give me my IntelliSense. And then it's going to be, what's the command for that? Do I just call it from drive base or swerve input stream? Actually, it's whatever I call the swerve input stream, right? So it's angular velocity. Am I going insane?
No, that sounds right.
Awesome. I messed up my code somewhere. So, future programmer, current programmer. Actually, there's a programmer line in the call. Fix that. Aim at. That's not here.
Oh
Where
wait,
is
it's
it?
in a swerve input stream. You have to go down
Yeah,
to his,
that's what oh wait, did I just type angular? I just okay. Drive angular, drive field, angular velocity dot aim at.
No, that is the command. That isn't the swerve input stream. The swerve
That's
input
not
stream is fed into the.
for drive. Okay, it is.
Because I tried using it and I was like, wow, this is great. And then Nstrike immediately said, no, it doesn't work. And I was so sad.
Drive angular
It
velocity.
does work if you don't want to use it for shooting on the move.
What else would I use it for?
You sit still, push a button, and shoot. You know, when games that have protected zones, that's perfect. That's all you need.
Oh.
Field dot constants. I think I have a field constants class. Field constants? I do have a field constants class. Shout out to Mechanical, was it Advantage for that, by the way. Hub. Can I get my IntelliSense? Thank you. Does this not output a post 2D?
Does it?
You know what? Future problem. Okay, but hypothetically, that's how you would do that, right? Don't put it drive base, set default command. You would put it in a button somehow, like driver controller dot button A, while true. You're gonna call this angular velocity dot aim, and you're gonna aim at the hub. So ta-da! Actually, it wouldn't be angular velocity. We direct angle, right?
It doesn't matter.
Yeah.
Oh.
The only thing that's
It's
confusing too is how each joystick works.
yeah, and you would do .aim to set where it's going to aim at, and .aim wow to actually convert the sort of input stream from ignoring the joystick controls and just aiming. Well, it wouldn't ignore all joystick controls. It would ignore the angular velocity joystick controls, which would be either your heading or your angular velocity axes.
Okay. What did I break? Elevator? I don't know. Okay. I need to set that default command back. Okay. Photon PV tracking? Did you not see tables code yet? Chris. You also just saw that one. Yeah, no, this one's also here. Switching which. Where is it? Is it in your subsystem?
Well, one of the nice things about YAMS and YASS in general is that you can just, if someone makes it, it is able to be implemented in your own code with less effort than anything else,
Shooter
and with the
aimer.
same optimization.
Thank you, Nick.
Thank you. Thanks, Yams. Yams is goated. Okay. Whoa.
So there's like a lot of just random stuff in there because I was kind of debugging and never deleted half it. But so uh, basically
ahead.
the way the yeah, sorry, thanks. The way the code currently works is like it's one of the functions, but
Tell me when to
it
scroll. Yeah.
calculate yeah so like a general overview of what we do is you take the robot's position and then you calculate like the shot vector and like your hood angle and your velocity, your like turret velocity, based off like if the turret was or if the robot was completely still, right? Then you take your robot velocity and then you add that to your like the predicted goal location kind of thing, to figure out where like the goal would be after like a certain amount of time, and
Hold up.
then
Right here. Right here. Right here.
that's where you aim instead. So, uh, yeah. So okay, that is for like that's like the math for the hood angle and the velocity. So yeah, I'll just go over this really quick. So
Are you sharing your screen
basically,
right
what
now?
this is,
Or you want like me to share
should I share my
screen?
screen?
I mean, it'll probably be easier for you to talk to about it.
Oh yeah, that's true.
Like, how do I unshare my screen? There you go. Doop. Am I still recording? I've never started recording.
I've been recording.
Oh, I remember now.
Watch me like pull the recording
Okay.
later, and it's just like totally corrupted, and everything has gone wrong.
Bro, I had to check my sound and everything before this. Okay.
Yeah. I'll blame OBS.
Okay. So basically, the way that we like the way we aim, like if the robot's standing still, the way that we figure out the angle and the velocity is we basically make a parabola between the robot position and the goal position, right? I
Yeah.
think I have a Desmos graph of it somewhere. Give me
Holy
like 1 second.
math. Yeah, no, my brain, like, hub tracking, like, theoretically sounds easy, subtraction, whatever, and then it's like,
It looks so cool. Like
programming
this.
that.
That's like the coolest thing ever.
Yeah. Shooter. Oh yeah, the shooter calculator thing. Yeah, that thing's really cool.
Hammerhead made one, and it's like pretty nice as well. But yeah, if anyone wants to look at that. Actually,
See, I feel like I'm not smart enough. Past the a squared plus or ax squared plus bx squared plus c. I'm like, how do I put that? How do I make that useful for programming? Actually, no, that's just basic like kinematics, isn't it? Like if you really think about it, it's
exactly.
physics.
Yeah,
You see,
pretty much.
you see, when you put in the words kinematics, my brain's like, oh, that's easy. But then you put parabola. It's like, how do I use math class for real life purposes?
Weapons, missiles.
Okay, but they never teach you how to apply that stuff. They're like, here's a worksheet. Here's the standardized test.
A common topic in the other Discord is how most trajectory and shooting formulas have derived from military research in the last 60 years.
Yay, missiles.
The current shooting on the move code that's been floating around, that Ishwar from Redux made, was based off pure physics, and then there's a simulation that is based off a obscure paper about a warship cannon direction to shoot while bouncing on the waves at your enemy ship. That'll be added
Mm.
into WI-Lib in a few weeks.
Yay! I love having the capability of programming deadly weapons. So someone had a question about what's the difference between calling the method in periodic versus set default command. From my knowledge, setting the default command runs the command when there is no other commands being actively called on, and in periodic is going to be constantly calling that command all the time, every 20 milliseconds. And then let's see. Yeah, you said that setting the default command is the command-based version of calling it in periodic. Yeah. I've never touched a time-based robot before. They kind of scare me.
There was we used to have a t-shirt cannon bot, used to because now it's like gutted, and it was coded entirely in
Ooh.
typed robot. So that's
Ooh.
how why I have the trauma.
Your mentors are so old that they remember a time that there wasn't a command-based robot, and the command-based robot option at the time sucked ass.
Wow.
What?
You see, that's like FTC and like command-based programming. And then everyone's gonna have it next year, and it's like, whoa.
The op modes are disgusting. Oh my god, I can't.
We're gonna have op modes.
Why? Lord.
We're gonna have a system core discussion in like a couple weeks. That sounds fun. Oh, that's what my Minecraft weekly workshop should be on. Just talking about system core.
The new blue, what's it called? Like the blue box or whatever. It looks pretty cool though.
Yeah, I just don't like change, man. I got used to this. I have to relearn it. Okay, I've been like falling off the chat. Okay, it's my turn to screen share. Are you? Or actually, no. Are you? Do you have something more to showcase about your code? Like, or you think it's explained it?
I mean, someone in chat was asking about like how we like calculated the angle and stuff. So
Please.
Yeah, you
like,
should answer that question.
should I?
Math me.
Yeah.
Yeah. So basically, what we do is we take the robot position, a point like a few like think it was 21 inches in our code above the I guess rim of the hub. I don't really know what the word is for it. And then we take like the center of the hub, right? And then mathematically, if you have 3 points, you can there is one unique parabola that fits all three, right? So um like in this like Desmos graph, obviously you can change like your clearance level and where your turret is, and then it'll figure out the let me find this. It'll figure out the angle and the velocity. The actual math for it is kind of complicated. So it's basically, since you have your 3 points and then you have this parabola, you can make a matrix that's a, let's say x1 squared plus b x1 plus
So you're
c
saying
is
words
equal
that
to
like
y1.
I learned this stuff in like math class, but like wow, application. This is crazy.
A lot
So,
of this stuff is just kind of stupid, I'm gonna be honest.
oh, this is interesting.
But yeah, you basically. So, what were you saying?
No, no,
This is
sorry.
interesting.
Yeah.
Okay. So basically, you can create like three different equations, right? Based off your ax squared plus bx plus c.
Yeah.
Um, so since you have these three equations, right? Because obviously, if you have a point x1, y1, you can plug in x1, you'll get y1. Yeah. So you have this, right?
Mm-hmm.
And because you have this, you can split this into a matrix, right? A matrix of the form.
It's a 2D
Let me
matrix.
see how big it is.
Oh,
Yeah. So
yeah.
I suppose it's more like multiplication of two different matrices. So you'd have
Oh.
your X matrix, which will have like all your X stuff. So it'd be your X1, X2, X3, X1, X2, X3, and then this we would just count as like I think one, and then that's times your ABC matrix, right?
Oh,
So
that's
let's
Yeah.
just denote that by capital A, and then that times your A matrix would be equal to your Y matrix, right?
Thought how
Um,
the matrix
and then
calc.
based off that, you basically, yeah, you're trying to solve for A, right? So you
Oh.
take out X, you multiply by X inverse, and based off that, you get these big formulas. Um,
Yay! See,
yeah.
in theory, it's easy to do
So
it
it
like on a
looks
piece of paper, but then like you have to program it, and how do you program it? That. Oh, looks like
because
someone.
the like
Yeah.
we have
Mhm.
sorry, oh, what were you saying?
Someone says that your method can be improved. Also, the other person had a question or asked, so does your shooter speed need to be adjusted since you're shooting on the move, or it's the same as you're shooting still, if you have a fixed angle? To answer that question, there's something called Newton's first law, which really sucks, and it's called inertia.
mm,
And when you're moving, you're also that ball also has a translation speed on the like not towards the hub. So you're gonna have to adjust your shooter speed to kind of adjust for that inertia. I'm guessing that's my answer for that. And then yeah. Anyways, you can continue on now.
Uh, Um, anyway, yeah, there's definitely a way to improve this because some of our points we know are gonna stay still. Like our clearance point is gonna stay still, and our like center of our hub point is still gonna stay still. These equations can be dumbed down like a ton. I just never actually did it because I don't know, I was kind of bored and didn't. Yeah. Anyway, so with these, you can get your A value, your B value, and your C value for your ax sorry, your x squared plus bx plus c, right? So now that you have those, I have the calculations here. I honestly don't remember how I got this. I think
You got
might have like
this.
taken the derivative or something of the equation. Um,
um,
oh yeah.
Matt.
Okay, so for this, to figure out the angle, because the angle is always going to be positive and between 0 degrees and 90, right? Because you're not going to be shooting into the ground. Hopefully.
Yeah,
I don't think you should be shooting into the ground. Yeah,
that's the
so
new meta,
really all you
guys.
have to do is you just have to take you just have to take the derivative of this, which gives you 2ax plus b, right?
Yeah.
Um, and then you take the you find the derivative at like your turret point, right? So
Hmm.
um, if we find it at our turret point, which is this, um, yeah, so that gives you our slope, quote unquote, right? Like at our turret. Now,
Yeah.
with this slope, what you can do is you can take the arctangent of the slope to get your angle, because the slope
Hmm.
is just change in y over change in x, right? Yeah.
Yeah.
So that gets you your angle. Um, velocity, I think I took this equation, which is basically derived from if you take in pre-calculus, I'm
Yeah.
pretty sure if I remember correctly, you have these like you learn about parametric equations and like ballistics or something like that. I don't remember. But
Yeah.
basically making parabolas with parametrics, right? Yeah. So
Mhm.
this is basically taking those parametric equations and combining them to make a singular y equals whatever function.
Yeah.
Um, and then using this, you can basically have set that equal to b or something. Um, yeah, and then yeah. So
Math.
that's basically how you get the velocity. Yeah. So in our code, your turret position would just be your robot, and then transformed by wherever your turret is on your robot, um, and then your turret y, obviously, right? So that would be your x1, y1. Your x2 and y2 would basically be the like hub radius, quote unquote, between like the hub and like the rim, and then your like the height of the hub plus the clearance. That would be your y2. Then your x3, y3. Um, we're assuming x is just or x3 is 0, and then your y3 is like the inside height of the hub.
Yeah.
So with that, you can make your parabolas, and then since we never
Hmm.
actually use c, there's no point in calculating it. That was just for visualizing it. So with that, you get your initial like hood angle and your initial velocity, right?
Is this your velocity while the
So
ball is
there's a
moving?
lot of commented
Or
code
like,
here.
What's up?
is this the velocity of the ball like while
This
it's moving,
is
or like the robot's moving, or is it static? Also, by the way, you're only sharing your browser. You're not sharing your full screen.
oh, am I only? Oh my gosh,
Oh, were you
that would
showcasing?
make sense. Um,
Also, hello everyone who
yeah.
just joined. We just went through kind of like the calculations on how you calculate your velocity, which is and a long story short, lots of math, parabolas, and yeah, the codes in the free code in the comments or where the chat is, yeah,
Chat video.
of this channel.
Oh shit,
Yeah.
we recorded the chat as well. I'm only
Sorry.
recording the stream.
Yeah, if you can go over your code again, that would be great. Because
I think that 2181's code is going to be as popular. It's going to be as popular as Bronkbots's code from last year was.
Oh, you should probably set up repo history, by the way, to make sure like you're getting all the stats for everyone clicking on your link, because if you don't, valuable impact material is going away, slipping through your fingers. Every 100+ people could impact your chances for impact.
Yep. You know, good point.
Set up repo history after this, because GitHub only records every 14 days.
Oh, seriously? So it could like gets rid of everything before that,
Yeah.
or
So rest in peace, all of the stats I could have gotten from last year's code.
I look at that
yeah, it sucks.
pretty infrequently, but like a lot of people were interested in our alignment code specifically and the drive propose code.
Yeah. See, I like that one too. That was very cool. Anyways, code shooting on the fly. Everyone, this is what
All right.
everyone's
Yeah.
here for.
Okay. So basically, the actual function we run for figuring out our like where we should aim on our on the XY plane, I guess you could call it, and then our hood angle and our velocity is in this function, get shot data. So it returns a record that I created called shot. I kind of took this straight off of like 5000's code because it was like a really nifty way to do it. It's basically, I think I have it all the way down here. It's just it's a record that contains the velocity, the hood angle, and then it says target, but it's like your angle on the
Uh,
XY plane that you should shoot at. Yeah.
That record is that a Java thing or is that like what is that? Access modifier.
Is a Java thing.
Um. Yeah.
Oh, never seen that one before. Whoa, learned something new.
The docs says that it's intended to serve as a simple data carrier. So it just has, equals, hash code, and two strings.
Mm, okay. So it's like I'm guessing it's recording the shot data, or is that?
Yeah.
It's more like an
It's
SQL data.
so
It's more like an SQL
um
database line. It is nice and easy comparison data type.
Mm,
Ooh, that's pretty cool, actually. That is very nifty.
mm-hmm.
oh yeah. So basically what we do is so when you run the function, it takes your robot pose and then it adds a little bit of latency, because obviously it takes time for the like code to run, right? So
Yeah.
this constant seems super high because it is. I think it's like something specifically with like my computer probably. Um, but it only like really works if I have it like this high. Uh,
Is this computer
but yeah,
latency?
basically we
Like, latency of your computer, or like latency of like getting that information back into your driver station?
um it should be the latency between when the when you like want to send the command and then when you actually shoot the ball.
So it should
Yeah,
be like 20 milliseconds, but that's not like an
yeah,
ideally possible time.
yeah.
How did you get this number? Did you just like guess?
Uh, Guess and check really. So this is like only sim tuned. Um,
Mm,
Basically, you can just run in sim, obviously, right?
yeah.
And then I just checked values until the ball started like more or less going into the goal, and I just kept that number. Yeah,
Mm, okay.
yeah. So basically, it's just you take your the robot pose that you feed it, and then transform it by latency, right? Then that's the
Hmm.
robot pose you're going to use for like the entire function. Okay. So what we do is it goes in steps. So first, our first step is we take our robot position and our speed. I don't know why it's feed at the speed variable here. I don't actually use it, but you give it your
Hmm.
robot position, and then
Yeah.
you figure out the angle that you're gonna shoot at and the velocity you're gonna shoot at, right? Like the just the hood angle, not like your XY angle. And
Mm-hmm.
then you figure out the vector between your robot and then the goal, right?
Mm-hmm.
Then from there, what you do is you figure out the time of flight between when you shoot and then when the ball is going to land at the goal, right? That's super
Yeah.
important for figuring out like shooting on the fly, like while you're moving, obviously the ball is going to get your movement, right? So
Yeah.
you have to aim a little bit before that kind of thing.
Mm,
So with that, since you have your time of flight and then you have your chassis speed, what you can do is um, you can figure out your where your like goal would more or less like be relative to the ball um, once like that time has passed, right?
yeah.
So once you figure out like where your goal is relative to the ball after it should
Yeah.
land, you can figure out. Let me see. You can figure out the vector between your robot and then where your goal should be, right?
Yeah.
So the math behind that is it's just vectors. Basically, you have your
Right.
the vector between your robot and the goal, right? Um,
Yes.
and then you have your robot velocity vector. So when you take your robot velocity vector, you're adding that to the vector between you and the goal, right? So
Mm-hmm.
then you have a new vector, right? So
Yeah.
to get that back the vector back to pointing at the goal, you have to add the opposite of the robot velocity vector, right?
Mm-hmm.
Yeah, because it needs to balance out. So that's really all this
Yeah,
is doing. Um, so you
physics.
figure out where the goal would be. You figure out the like the vector between your robot and where the goal would be, and then that's where you're gonna aim on your XY plane. Okay.
Yeah.
Then this is supposed to give you better time of flight estimations, but yeah, and then once you have that, then you have to recalculate your velocity and your hood angle because technically um, you're shooting at like I don't really know how to describe it. You're technically shooting at a different target, so you have to recalculate that stuff
Yeah.
to properly
Well,
aim, right?
because
So
you're moving on the
you have
fly,
your
so
yeah. So with that, you find your the ideal like hood angle and velocity, but not between you and the goal, but you and like where the goal would be, right?
hmm
So that gives you your hood angle and your velocity, and then with because you know where the goal would be, you can figure out the vector between you and where the goal would be, and that gives you your angle. So with that, what we do, let me return that, and then currently I think I have it set up in the not in this in here
the
on Sublime,
magnitude of the
yes.
vector offset from the hub. Um, yeah, if you search up, if you look at that blog post that Enfrek just sent, that would basically cover everything he's talking about right now, to pretty simple terms. Recommend reading it as it'll definitely help you understand it a lot better, and it can help you even make your own on the fly code. Yeah. Okay, continue.
Yeah. Okay, so what we do here is so over here we run the get shot data function, and
Yeah.
that gives us our hood angle, our velocity, and then our turret angle. And then right now, this stuff is specifically for simulation.
Why is this
Uh,
like a plus system?
oh,
Is it?
because I don't know, I was too lazy to make it like into an entirely different thing, so I just added it here for quick testing. And then yeah. So basically, with that, what we can do is hold on, let me run this in sim really quick so I can show you guys.
And you're using a 500s or 5000s was it fuel ball simulator or like
Yeah, I'm using their sim code. Yeah.
yeah, can you quickly showcase right that while we're waiting for Sim to boot up? I don't think we're showing that. You're seeing that by the way.
Oh, yeah, of course. Hold on. Let me change my presenting settings.
You share the whole screen, yeah.
Let me see if
Yeah,
I can.
so if you're unaware, you should search up their GitHub later. It's Team 5000, easy to remember. Have a open source code where you can basically input and show all your or basically simulate your field trajectory. So it's that right there. How do you control like when the field's like intake or outtaking? Actually, I've never seen it like used before. I mean, yeah.
Um, so currently I don't have the intake figured out. I was messing with that, I think, our last meeting, and then I think I switched the photon vision stuff, and then I never actually figured it out. Um, so I don't have the intake handled right now,
Yeah.
because like if you're going straight off 5000's code, if you use Advantage Kit, you should theoretically just be able to do it normally, right?
Yeah.
Um,
But
if
you
you're
need to
not going to
simulate.
use Advantage Kit,
You need to be able to
sorry,
figure
you
out
cut
what,
out.
right?
Yeah, yeah. Um, but basically, in simple terms, this fuelsim.java, all it is it's really just an instance of fuel on the field. That's really like well what it is.
Mm-hmm.
Then over here in turret visualizer, this is just for sim. Um, ignore these, I added these. So basically, what it does is you feed it your pose and then your your speed, right?
Yeah.
And then what it does, it takes the turret hood angle, and then your sorry, what's it called? Your velocity, and then it uses that to make an x vector velocity, a y vector velocity, and then a z vector velocity, right?
See?
Um, this won't simulate what's it called? This won't simulate drag and the Magnus effect and stuff because that's really complicated,
Yeah.
and
Mhm.
I don't want to add that.
No
So
way.
yeah,
Yeah.
um, it basically takes those, it takes your initial position, and then it runs a loop
Mhm.
where each iteration is what is this? 20 milliseconds, I think. Yeah,
Yeah.
and it just runs a loop to figure out where the fuel would be at each point in time. And then with
Mhm.
that, it updates the fuel's position in Advantage Scope, and then that like helps you visualize the fuel. So over here, as you can see, our robot is over here, right? So if you go on the teleop, if I shoot, oh, hold up, it's really laggy. But we can see is it is going into the goal. And then
Whoa.
if I move over to here, okay, it's super laggy. That's my bad.
You're running a lot
But
of stuff
you
right
can see that.
now. Mhm.
Yeah, hold up. Let me. Okay. You guys can mess with it on your own, I guess, then, because it's not. I'm not going to be able
Yeah.
to get it running properly. Um, but yeah, that's shooting on the fly, I guess.
That 3D sim, that's yeah, that's Advantage Scope or is that Advantage Kit? Like,
That's Advantage Scope. So Advantage Scope is the actual like thing used to visualize. Advantage Kit, I'm pretty sure, just helps with logging the stuff.
mm,
So some teams do, some teams don't. Our team doesn't, so I had to change some stuff in 5000's code. But yeah,
okay, so your code doesn't use Advantage Kit, but 5000 does. So there's the two examples on that.
yes.
Does anyone have any questions? Go ahead. On anything. Let's see. It is 9 o'clock, so we're gonna open the floor for questions, as well as maybe suggestions for the next topic. Because we in fact did not talk about simulation today. Shocker.
This was way more
Well,
important.
yeah, this was way more important. Yeah.
Well,
Let's
sim is
see.
easy. Sim is easy.
Sim is easy, but it's also like they someone needs to say it out loud.
Why do people just not take your word for it?
I mean, like reading is easy, but someone has to teach someone how to read.
English
Mm-hmm.
is not easy.
I don't know. What I be doing instead of watching the Super Bowl? This is more entertaining. Why watch a brown ball get thrown around when you can have a bajillion yellow ones? And you can simulate it too. Um, we have been playing with okay, Holy Artist says that we've been playing with this version and another version I shared in Discord before. This version that he's talking about uses pure math, whereas the other version use lookup tables. Um, okay, that's catching up on the chat.
The lookup
Oh, the
tables.
Super Bowl. Oh, the Seahawks won. I have no feelings for any of them.
The match isn't over yet. That's just the current
Oh,
score.
do you think? Do you think they're gonna sweep?
I don't care, honestly.
Yeah.
The Bad Bunny halftime show was peak. That was enough excitement for me.
Yeah, I gotta go rewatch that.
No, you didn't catch it. No.
No, I was kind of like programming.
Yeah, I had my laptop on my lap and I had the show going on the TV and I was just working.
Yeah. Okay. Well, I guess next topic. Let's see. Gotta brainstorm ideas. Probably sim. I didn't finish that motor slide presentation yet. Um, I forgot I was on. I think it was like tuning.
Uh,
No, I
yeah, you're on tuning. You already discussed the motion profiles with both trapezoidal and exponential, right?
We've done that.
yeah. I just need to talk about actually like tuning, which is like all the steps of that. But that's like I feel like that's better done in real life. I can make a vlog once I like tune the robot that I have to tune. That's gonna be actually it's gonna be a lot quicker this year. We have live tuning.
It is going to be a lot quicker this year. If you're using YGSL 2027, it will be a lot slower because you have to tune the simulation of YGSL 2027 like it's a real robot, and that's painful.
Didn't you
If
make
I
it?
recalled last time, tuning in sim for YGSL doesn't exist that
It doesn't.
well.
It
Yeah.
doesn't. But YGSL 2027 is a complete overhaul of YGSL, um, which is based off of EMs. It will require a decently strong computer, which is a reasonable expectation nowadays. Um, but yeah, it is painful.
For the
I'm still the huh?
How do you get access to YGSL 2027? Is that just for the vendor depths? Because that only goes up to this year.
Oh,
Be a founding team.
Oh, okay. Y'all have fun with that then.
you're from 2181, right?
No, I'm from 8816.
Oh, yeah. It's if you're a founding team or a partner team, you are able to get access to YGSL 2027. Um,
Mm-hmm.
it's just not ready at all yet.
Partner team rock.
That'll be open for beta testing pretty soon, probably in the off season, or maybe if we confirm it that it works sooner than later.
Yeah, definitely an off season at this rate. I have a bunch of other things
So
before
my
that.
robot is not being the guinea pig for this. Awesome.
Yeah, I think Gabe would kill me if I let you guys do 2027, which is completely untested for your first competition.
Yay.
But think about the
Do they
angle
have to
though.
know?
Think about the bot just like going straight off the ramp, just into the sky like a missile. That would be amazing.
You
You
see,
know,
what
it
I
is a
more imagine the robot just not moving is a higher scenario. It's gonna stand there like a rock.
You gotta have dreams. You gotta shoot for the stars. Literally.
Really
possible.
shoot out the world.
All I can say about YGSL 2027 is it will look prettier and be more functional than 2026,
Yay.
Woohoo.
but have less features at the same time.
Ooh.
Software development hell.
Yeah, basically. I removed some of the extraneous things just because they don't really fit into any standard paradigm and they really shouldn't exist in the first place.
For example,
Arbitrary feed forward voltage values.
everyone who used that, you can warn the three people. I don't know of
It's
any team.
everyone who actually uses the force calculation in Pathfinder and Choreo and passes those on to the motors. It doesn't
Okay, so that's a
really
lot.
add much of a benefit,
Yeah.
but it's a thing. It's a hyper optimization that's not really necessary.
System core. So it's new hardware, but it's also an overhaul on programming or WIP-lib like itself. So what
Mhm.
it's gonna add is op modes to FRC and command-based programming to FTC. And so for FTC, I'm like, this is great. This is awesome. I'm so excited. For FRC, it's like, ooh, op modes. Which is has its pros and cons. Pros being like you can actually separate autonomous and teleop. Um, con and also testing mode. Cons would be that I'm guessing you have to program everything 3 times over now or whatever.
Not really.
Not
With
really,
op
but
modes, with op modes, you can have subsystems, and the only thing that's bound to op modes would be a certain robot container class, but your subsystem is not op mode specific.
Yeah. So it basically just splits the robot container in like 3 parts.
Mhm.
Yeah. Man, rip my 1,000-line robot container. Oh, I was meant to showcase that today. I guess you know what? That can be a next week thing. Let's see. Yeah. Big software changes next year, 2027. Yeah.
How did you accomplish that, Chris?
What did
How old
do you
is
have a RAM leak on your reel and have it?
How like
Didn't we have that problem actually? I'm pretty sure we did have this problem.
We didn't crash our computer. We crashed the Rio.
Man, my computer really sucked. Because our fix was getting rid of like 15 print statements. How did you crash your computer?
was outputting the
Printing out
Yeah.
every single allied character of pi with separate print line statements. Guys, come on.
high verbosity wasn't enough for you people. You guys needed more.
I mean, if you've seen the YAMS telemetry for velocity.high, it literally includes everything that teams who are obsessed with logging would want.
Not Chris though.
It
Chris
even
more.
does Chris need the derivative temperature? Because we don't offer that. We just offer temperature.
The rate at which
Um, what are we gonna use derivative temperature for?
I need everything.
You could use there is one use case for derivative temperature.
Please.
You could use it to determine how fast your motor is going to die.
Awesome.
Wait,
I
that
can
sounds
smell
useful.
with my nose.
I might side with Chris here. That's pretty useful.
I don't know, man. Just sniff the motor.
The
Huh, it
problem
smells
is
smoke.
it only works once.
I feel like we've lost the plot.
We had one?
We lost the plot at the beginning of the call. We haven't done anything we said we would.
Well, thank you everyone for joining us on today's workshop all about simulation. I got to end the video because yeah. Thanks y'all for coming here today. Y'all can still keep the chat going. Yeah, thanks. Next week we're gonna hopefully have a workshop, unless actually I won't be having that workshop. Hopefully maybe someone else can host it. Because Valentine's Day is a very busy day. Unless someone offers me free code, then I will be on.
Bye.
Bye bye everyone. Bye bye.